Lesson 2, tangent lines and the derivative. As I mentioned, we officially get to talk about the definition of the derivative. However, it's very much like what we were already kind of working on in lesson 2.1. Two main concepts in calculus. We're going to spend most of the rest of the semester, they call it tangent line problem. Anytime you start thinking about tangent lines in calculus, your brain has to think derivatives. We're thinking derivatives, okay? Second semester, we'll talk about area problems, which are integrals. Integrals are kind of going the opposite direction of derivatives, but both of these ideas relate to limits. And right here, you specifically see how derivatives relate to limits today. In the previous lesson, we applied the difference quotient to a function and found a general slope formula. This calculated the slope of a tangent line at any point on the curve, provided the limit exists at that point. The general slope formula is also a function. It is called the derivative function. Okay, now it's the derivative of f of x, most commonly read f prime of x. So when you see f, and that's a single mark, so it's like a single quote mark, okay, that is f prime of x. A function that has a derivative as a point is said to be differentiable. So being differentiable and being able to take the derivative are one and the same. So our definition, okay, this is something you'll want to be familiar with. The derivative of the function f with respect to x is the function f prime, whose value at x is m, which, you know, thinking like slope here, f prime of x, and then this is what we saw yesterday, right? The limit as h approaches 0 of f of x plus h minus f of x all over h. When we think about this, and of course provide the limit exists, when we talk about definition of the derivative, it's limit of the difference quotient. So the difference quotient being that f of x plus h minus f of x all over h. So it is limit of the difference quotient and it is also finding slope. When we talk about being slope, it's slope of the tangent line. So just kind of all stuff to tie it together. A side note here, the domain of f prime, which consists of all values of x in the domain of f of x, for which the limit exists, may be smaller than the domain of f. If f prime of x exists, we say that f is differentiable at x. Okay, so we'll talk a little bit about the domains as we go when necessary. Okay, proper notation. We'll use several of these. I'll be honest, several of these ways to express derivatives are more common than others. But what it comes to at AP Calc is you need to be familiar with all of them so you know what they're asking. You know that they're asking you to find a derivative when you see each of these notations. Okay? And I will say, we're going to be finding the derivatives using this big long definition right now. Eventually, there'll be a nice neat rules you can follow. For the test, like for a quiz or a test, if I say use the definition of the derivative, in order to get your full credit, I have to see the definition of the derivative worked out appropriately, right? Okay, so that, because I need to grade that we can do that. Now, honesty, okay? Right now, we're going to practice it a bit, get familiar with it. Come AP exam time, I would be shocked if you ever saw something about find the derivative using the definition of derivative. Okay, I don't think they'd ever require that. But you need to be able to recognize this setup because they might give you something in this setup and expect you to find the derivative. That would be easy if you recognize it as a derivative. Okay, so proper notation. One of the most common ones, f prime of x. Okay, some benefits and pitfalls. It's our formal. It names the function and the independent variable. So it's telling you the function is f, the independent variable is x. It's a formal way. We know f of x is the same as saying y equals, right? So another way to say f prime of x is to say y prime. It's kind of the shorthand version. It's brief. It doesn't name the independent variable, though. So it's not saying the derivative with respect to x. It's just saying the derivative. The other most common one that we're going to see is dy over dx, or I usually read it dy dx. Dy dx, or the derivative of y with respect to x. So it uses d for the derivative, and it names both variables. The comment is awkward to use. Okay, it's probably of these three, it's probably my least favorite to use, but it does definitely tell you it's the derivative of y with respect to x. You sometimes see df dx. df dx, the derivative of f with respect to x, similar to earlier. Emphasize the function's name. I rarely see us use it. Notice it says awkward to use. But very similar to dy dx, just it's stating that f is the function. And then we use this one in certain circumstances. ddx of f of x. So, or ddx of f at x, or the derivative of f at x. ddx is just saying that take the derivative with respect to x. And so it's saying take the derivative of f of x with respect to x. It shows the differentiation in an operation performed on f. We sometimes use it when we show that we want to take the derivative of something. Okay? Goodness, come on, next page. There we go. So, graphically, the derivative of a function at a point P is the slope of the tangent line to the graph of y equals f of x at P. So again, when you hear derivative, derivative is the slope of the tangent line. Okay, that's got to be a connection there. Derivative, slope of the tangent line. Because if you see a problem and it's asking you to do slope, realize, oh, hey, they want me to do the derivative. Numerically, the derivative at a point is the limit of slopes of the secant lines or the limit of the difference quotient. So that's a numerical. Verbally, a function is said to be differentiable at a point if and only if it has a defined slope. So the slope has to exist at that point for us to be able to take the derivative. If a function does not have a tangent at a specific point, then the function cannot have a slope and it's not differentiable. We'll talk about things like hard points, like curves. Okay, yeah, you can always take the derivatives. But if you have like a hard point or something where there's a vertical tangent, then we run into places it's not differentiable. Okay. Here's where the work comes in. Use the limit process of the derivative to find the general formula dy dx for the derivative of f of x equals 2x squared minus 3x. Okay, so if I write some proper notation here, we're going to be doing dy dx, okay? And remember the formula, the limit as h approaches 0 of f of x plus h minus f of x all over h. So that's the limit process to find the derivative, and they give us the f of x there. Okay. I cannot stress enough, as annoying as it is, keep rewriting that limit each time. I know it's so easy to just, I'll remember its limit, I'll drop that off. A, it's not proper form. Okay, you can get dinged for that. But then B, we'll forget to do the limit at the end if I don't keep putting that there. Just going with past practice. Okay, you ready? You guys know how to do this part, yes? It's what we've been doing. It's what you did in homework, right? F of x plus h. Every place I see x, I'm replacing it with x plus h. So 2x squared becomes
2x plus h.
2 times x plus h squared minus 3x minus 3 times x plus h. And then it's minus f of x. What is f of x? 2x squared minus 3x. Notice I put that in parentheses, yes? Either put it in parentheses or go ahead and apply the subtraction.
I thought the 3x plus h would have been the minus 3x. Well, where did you get the, you just added at the end always?
So f of x plus h, this is f of x plus h. And then minus f of x, this is minus f of x. Does that help explain whatever your question was in there?
Yeah.
Okay. I can tell there's confusion about what came from where, but the first time I do f of x, I'm plugging in x plus h. And then right here, subtracting f of x is just subtracting it as it's given. Good? Okay. Now, you guys know what we need to do, yes? And guys, as I said, this isn't forever. We're not going to be doing this all year long, okay? By the end of the year, you'll forget how to do this because we haven't done it in so long. That's not good when it comes AP review time, but okay, so can we do x plus h squared and multiply it by 2 at the same time? Are you that talented or no? I don't know. So for foiling, and guys, I don't write it out. I'm trying to force us to use our brains, but do you have every right to write it out? Most definitely. Write out as much as you need. I just know a lot of times you guys get annoyed if I write too much out. So, okay, so for foiling, x times x,
2x
x squared times the 2. Your outsides and insides are going to go together, right? X times h and h times x, so that's going to be xh plus xh, which is 2xh, times 2, which is 4xh. Last, h times h plus h squared, and then
2h
plus the 2h squared. In all honesty, I just would have never dared to do that in pre-calc. I'd lose too many people. Hopefully I'm not losing you. Okay, minus 3 times x plus h is going to be minus 3x minus 3h. If you didn't already apply the minus on f of x, minus 2x squared plus 3x all over h. Don't forget to write the h on the bottom either. Are you one of the people that forgets to put the 2a under the quadratic formula and you just give me the top?
Yeah.
I've got pre-calc kids doing that to me right now, so. Okay, so equals the limit as h approaches 0. Oh, I guess we need to do some cleanup, don't we? Some of this will clean up, right?
Yes.
What's gone?
2x squared 3x
2x squareds are gone. 3x's are gone. 4xh plus 2h squared minus 3h all over h. Is this what we expect to see? What did I kind of suggest yesterday? If this is done correctly, everything on top is still going to have an h in it. If you get to a point and not everything has an h in it, I would backtrack and see if you made a mistake. Okay? Now, I don't know, are you talented enough? Did you go ahead and factor your h out as you were writing down this step?
I did.
That's doable. Okay? The limit as h approaches 0, h times 4x plus 2h minus 3 all over h Good news is that h's cancel. So now I have the limit as h approaches 0 of 4x plus 2h minus 3. How do I take the limit? Plug in 0 for h. That yellow is probably not the best color to use, but can you see it at all or not really? Okay, sorry. You know what you're plugging in though, yes? There's a 0 with an arrow pointing to the h. I'll avoid the yellow again. Although it works for crossing terms out probably better. Now, you plug in 0 for h. First of all, I drop off the limit now because when I plug that 0 in, I'm taking the limit. What remains?
4x 3.
4x minus 3. Okay. So officially, I'm going to bring it back together up over here. dy dx is equal to 4x minus 3. So 4x minus 3 is the derivative of 2x squared minus 3x. Man, so much work for something so easy
So easy.
in my brain.
Then I say we just skip this part.
I can look at this and know the derivative just by looking at it because I know my rules.
What?
So
Wait a second.
No,
You just drop the x off the 3 and
you
square
bring
the
and you
4.
square the first, and then you get 4x minus 3.
we'll see if your rules apply here. Keep going as you can figure them out.
Yeah,
We can just skip the rest of
it's
this.
just one.
Well, I'm going to go on to number 2.
Next one.
Let's practice again.
This one.
2x.
This one.
Given y equals x squared minus x, use the definition derivative to find f prime of x. Now, they're saying f prime of x. Just realize y is the same thing as f of x, right?
Just lots of different ways to write to just.
Pretty much, yep. And my job is to introduce you to them. So that, because what I hate is when we get to an AP question and it's like,
What is that?
what is that symbol? Like, that's my hope is that you'll at least be like, oh, I think that's one of those things she showed us as a derivative. Okay. The limit as h approaches 0. Can we go ahead and start plugging in? I don't need to write the original definition, do I? Okay, f of x plus h. Every place I see in x, it becomes x plus h, right?
Yeah.
So, x plus h squared minus the quantity x plus h, right? That's your f of x plus h. Minus f of x. So minus the quantity x squared minus x. All over h. You good? I know you guys are kind of working on your own, which is good. Keep check with me though. Make sure you don't go astray. Limit as h approaches 0. We're ready to multiply out. Are you getting quicker at this? X squared plus xh and xh, so 2xh, plus h squared. I'm subtracting, so it's minus x and minus h. And I'm subtracting, so it's minus x squared and plus x. All over h. Did you forget the h again? Okay, consistency there at least. The limit as h approaches 0. Did some stuff happen?
A little bit.
X squareds are gone. X's are gone. I end up with 2xh plus h squared minus h all over h. If you haven't already, factor out the h on top. Then I have 2x plus h minus 1 all over h. As expected, everything on top had an h, and the h is canceled, right? So then it's the limit as h approaches 0 of 2x plus h minus 1. What do I do to take my limit? Plug in 0. And we plug in 0, what do we have?
2x minus 1.
2x minus 1. So in this particular problem, I can say that f prime of x is 2x minus 1.
Actually, I think you just multiply the first one by 2. Because if you square, you drop the x off the second one. No, you drop an x off both of them, and then you just multiply the first coefficient by 2.
I was gonna say add an x to
Factor out an x.
take the right x to the left. Add it. Get rid of the square root.
As we see more, maybe you'll find some more pieces.
See the rest of it.
You're seeing some of it. You're seeing some of it, but okay. Moving on. Now, notice here, it says alternate forms of the derivative. We have a couple of different variations of definition of a derivative. Okay, you need to be able to recognize each of them. Now, this first one, so the numeric value of the derivative at a point x equals a is also found by this. Now, notice, this is just saying, okay, if a is a number. So instead of it being x, if you have a number. So this is saying, okay, the derivative at a, it's saying you can do f of a plus h minus f of a all over h. Basically, you're saying you can plug in a number instead of x. You can also, like we did yesterday on one, you can wait till you get to the end and plug the number in. Now, there's also a new form here, and this is the limit as x approaches a of f of x minus f of a over x minus a. This is usually called an alternate form of the derivative, and it's same idea but a little different. Okay. I'm trying to think, is this the one they also sometimes call the symmetric derivative? I don't remember if we learned that in a different lesson or not, but okay. Of course, both of these, provided the limit exists. For all a for which the limit exists, f prime of x is a function of a. Okay. Example 3. Ask us to use the alternate form of the derivative to find f prime of a for f of x equals square root of 3x plus 1 at a equals 1. Okay? So when we talk alternate form of the derivative, I believe, yeah, we're going to use this one here. They tell us that a is 1, yes? So right there, we can use a as 1. We're going to use more numbers than variables here, which is nice, right? The other piece I would say maybe get started by finding, can we find f of a? So if f is 1, f of a means I'm finding f of 1 in this case, right? What is f of 1? Don't think calculus, just think basic algebra.
Oh,
2.
yeah. Square root.
right? So f of 1 is just saying plug 1 in for x, right? So it's the square root of 3 times 1 plus 1, which is the square root of 4, which is indeed the square, or 2. Start to say the square root of 2. So we can state that f of 1 is equal to 2, correct? So we know that a is 1, f of 1 is 2. Okay, ready to set up this derivative?
No.
Okay, so we're going to find, it says f prime of a, so we're really finding f prime of 1 is what we're doing here. Okay, so it's the limit as x approaches a. What are you using for a?
One.
We're using 1, yes? So as x approaches 1, of f of x, what's f of x? Square root of 3x plus 1 minus f of a. What's f of a?
2.
It's f of 1, which is indeed 2. You guys with them? Denominator, x minus a. X minus, what's a? 1. Okay? Now, okay guys, we have this limit of this lovely fraction. Well, I never really talked about, but with definition derivative earlier, when h approaches 0, if you plug 0 in just at the beginning, you get 0 over 0. We get that indeterminate form, which is why we have to multiply it all out, cancel the h. Now, we have a different scenario here, but guess what? If I plug in 1, we're going to get 0 over 0. Okay, so we can't just plug in yet. We have to work with it. We have to manipulate.
Yeah.
I see a radical.
I really don't want to do it. Is it the only option?
I was gonna say.
Not reciprocal.
Or
Denominator?
Opposite.
the
Square root of 3x plus 1 plus 2. Yeah, whatever.
Conjugate is the word you're looking for. And what we do to the top, we're going to do to the bottom. Okay, so we got 0 over 0. When you have that 0 over 0, get that radical out of there and see what we can happen. So we're multiplying by the conjugate of the numerator in this case. And some good math should happen. The limit as x approaches 1. Now, when you multiply on top, keep in mind, what are we doing here? This is binomial times binomial, so we need to
Foil.
FOIL. What's the square root of 3x plus 1 times itself? 3x plus 1. We're multiplying conjugates. What's going to happen with my outsides and my insides? They're going to cancel. So then that takes us to last. Minus 2 times 2? Minus 4. Now, in the denominator, we're not going to multiply that out. Just let it be. We're just going to write it as x minus 1 times the square root of 3x plus 1 plus 2. More often than not, you don't have to multiply that other piece out. Something good will happen without us multiplying it out. Okay? Let's do some cleanup. What happens in the numerator?
Combine like terms.
Combine like terms on top, and this becomes 3x minus 3. Still over x minus 1 and square root of 3x plus 1 plus 2.
We can take the 3 out. I don't forget what that's called, but
So you see I know exactly what you were talking about. I was hoping someone would see it. On top, there's a GCF
Yeah.
of 3. So let's factor out the GCF. Notice I'm still writing limit every stinking time, right? So we factor out the 3. And what's in parentheses then? X minus 1. Over my denominator, x minus 1 times square root of 3x plus 1 plus 2. What just happens to happen?
They cancel.
A factor of x minus 1 cancels with a factor of x minus 1. Coincidence? Not really. So, how much more work do I have to do? Where do I want to continue this? So, I'm still writing the limit because I haven't taken the limit yet. The limit, as x approaches 1 of what's on top? 3. On bottom? Square root of 3x plus 1 plus 2? Well, I'm not going to get 0 over 0 now if I plug in.
So might as well plug it in.
So let's plug in. So we're going to take our limit, and when we see x, we're going to plug in 1. We're going to hope something nice works. So 3 over the square root of 3 times 1 plus 1, and then plus 2. Yeah, 2 plus 2, so 3/4. Okay, so we started with f prime of 1, and we found that it is 3/4. Okay, so we started with basically finding the derivative, but what we did along the way was we found the derivative at a specific point. So what this is saying, this is on this function at the point when x equals 1, the slope of the tangent line will be 3/4 because the derivative is the slope of the tangent line. So the slope of the tangent line is 3/4 when x equals 1. Okay? We're getting to be pros at this formula, I take it. It seems to be going pretty smoothly, which is good. Let's see. There's some observations down here, just kind of tying some things together. When finding the derivative at a point, there's 2 approaches. You can either find the general formula first and then substitute your x value in, or what we just did is we substitute our x value in from the start. Okay, if you had multiple x values you were going to need to sub in, I would say find the formula and then just sub in the values. That way you're not doing all the hard work more than once. So, if given 1 point, okay, if given 1 point, and we're talking about slope of the tangent line, instantaneous rate of change at x equals a. So that is IROC, right? That's our IROC there, and that is definition of the derivative. Slope of the tangent line, it's a derivative at the point x equals c, or f prime of c is equal to the limit as h approaches 0. And that's our limit of the difference quotient, or our derivative there. Okay, so that's if you're given 1 point and asked to find the slope there, we have to think derivative. That's the whole idea here. If you're given 2 points, well then 2 points now, we're actually doing normal slope, right? So we're doing average rate of change, or in other words, we're doing AROC. Over here it was IROC. In order to do AROC, it's just slope of the secant line, and so that's how you've been doing slope for years. F of B minus F of A over B minus A. Okay. Continuing along. Doing some more practice.
Yeah.
Okay. Let's see. This asks us to find the slope of the tangent line to the hyperbola y equals 2 over x at x equals 3. Now, there's a part A and there's a part B. Part A asks us to use what I would call the alternate definition. Okay, f of x minus f of a over x minus a. Part B is going to ask us to use what I call definition of derivative, or it's the limit of the difference quotient. Okay. In both cases, it says at x equals 3. So when it says at x equals 3, what are they trying to say there?
A is 3.
A is 3. Okay. So we're going to use A as 3. As I said, if I had to do this multiple times, I would just leave the A in and then plug in my values. But I only have to do it once, right? So let's go ahead and use the numbers. Okay, so they're asking us to find slope of the tangent line. We use definition of derivative. The limit as x approaches.
3.
I started to say 1. I'm stuck on the last problem. 3. Yes? Yes. Okay. F of x. What is f of x?
X plus h.
No?
2/3.
Just f of x is 2 over x. Remember, y is equivalent to saying f of x. So just f of x, that's with nothing plugged in, that is 2 over x. Minus f of a. What's f of a going to be?
With 3.
F of 3. And so what's f of 3 going to be?
2/3.
Now I'll take the 2/3. If f of x is 2 over x, then f of 3 is 2 over 3. Okay? All over x minus a, which is x minus 3. Okay. Well, of course, there's got to be something wrong, right? I mean, if you want to plug 3 in right now, guess what? You're going to get 0 over 0. So we need a plan. Right now we have fractions within fractions. No one wants fractions within fractions. How do we get it so we don't have fractions within fractions? Do we know?
Multiply by the denominator.
Multiply, yes, by the denominator. Well, wait. What denominator?
3x.
So what denominator are we trying to get rid of? We need to get rid of the denominators within the fraction, right? So we need to get rid of the denominator of x and the denominator of 3. So if we think least common denominator, least common multiple, we're multiplying by 3x. What I do on top, we're going to do on bottom.
That would be like 3x over 1, technically.
Right, like that?
Yeah.
Yes. Or at least, doesn't really matter on the bottom, but on the top, that's what you're going to want to think, definitely. Okay, so the limit as x approaches 3. Now, keep in mind, so we're going to take this 3x and we're going to distribute, yes? 2 over x times 3x becomes what?
6.
Because x's cancel, so 2 times 3 is 6. Minus 2 over 3 times 3x.
2x.
3's cancel, so 2 times x is 2x. Denominator, I'm not going to multiply it again. So I'm going to write it as 3x times the quantity x minus 3. You can multiply it in, but it's just going to create more work for you. Okay, continuing. The limit as x approaches 3 Because as it is right now, if I plug in 3, I'm going to get 0 over 0 still. Thoughts?
Take the GCF off the top again.
Okay. What GCF do we want to use?
2.
Yes, to an extent. Think ahead. Think to your step ahead, okay? I see the GCF of 2. If I factor out GCF of 2, what's going to remain?
It's backwards.
It's going to be backwards, yes?
Yeah.
What will fix that backwards?
Negative 2.
-2. Do you see that? Okay, because it's, and I'm not going to leave this, but if I just factor out 2, this is the backwards, right? The 3 minus x. Well, that's negative x plus 3, which is off by a negative is what you're seeing, right? So yeah, instead of factoring out 2, let's go ahead and get it all done at once and factor out -2. How fancy can you get? Can you switch as we go here? If I factor out -2 from -2x, it becomes x. If I factor out -2 from 6, it becomes -3 over 3x times x minus 3. And what just happened?
Cancel.
We have a factor that cancels. So the limit as x approaches 3 of -2 over 3x becomes -2 over 3 times 3, which is indeed -2 over 9. So we found our slope to be -2/9. So again, what we're saying is on the curve, y equals 2x. When x equals 3, the slope of the tangent line is -2/9. Okay?
Well, should we call it there?
Now I say we should do B. B ties in with A. And in fact, if you think about it, predict the answer for part B.
-2/9.
Yep. Now we have to do the work to get there, though. Just don't be shocked when it comes out the same. No complaining that, really, we did all that work? Yes. Okay, so now we're using the limit as h approaches 0, and we're using that difference quotient with it. Keeping in mind, f of x was 2 over x, right? They told us that x equals 3. And so we found f of 3 to be 2/3, right? So with that in mind, when I say x equals 3, that is our a value, right? So these right here, when we see a's, we're thinking 3s. Okay? So here we go. The limit as h approaches 0 of f of a plus h, but the a value we're going to go ahead and use is,
2/3.
well, the a value is 3. The function is, well, the function is 2 over x. Now, okay, think of this way. If f of x is 2 over x, right? F of 3 plus h. Or let me ask this. What would f of a plus h be?
2/3 plus h.
No?
3
3 plus 8.
Every place you see an X, plug in an A plus H, or 3 plus H. So that means this is going to be 2 over A plus H.
What? Oh.
Or we're trying to do 3 plus H. Every place you see an X, plug in 3 plus H. So instead of 2 over X, 2 over 3 plus H. We did not like that one, did we?
All these letters get me confused.
Fair enough. Fair statement. So f of A plus H is taking f of X, which is going to be 2 over, and instead of X, I'm going to use 3 plus H, minus f of A. Well, f of A is really f of 3. What's f of 3?
Two-thirds.
That one is the 2/3. All over H. Okay, limit as H approaches 0.
So we only had we just combined the A plus H, didn't we? Instead of having like 3 different spots, we just had 2 because we combined the A and H.
Are you comparing earlier to like where our equation we were plugging into had like x squared and the minus x? Yeah, the key is here, the equation we're plugging into only has an x.
So it really depends on.
It depends on what you're plugging into, how many times you plug in that A plus H or 3 plus H.
If there's 2 X's, then you have 2 spots.
You have to plug it in 2 spots, right?
Okay.
Okay. We have a problem in terms of fractions within fractions, right? Debating. I was not going to do this the same way, because we could do this the same way we did earlier, right?
It's almost the same. Just different letters.
Would that work? Let's try it. I'm thinking it might be less confusing, because what would we be doing? What would we be multiplying by?
3H. No.
3 plus H.
One denominator is 3 plus H. What's my other denominator? 3. So multiply by 3 and 3 plus H. What you do on top, you do on bottom. Maybe I don't want to do this way. I don't know. I think it'll work. Okay. Let's see what happens here. On top, what happens? The first fraction, 2 over 3 plus H times 3 plus H.
6.
3 plus H is canceled. 2 times 3 is 6. Minus 2 over 3 times 3 plus H.
Can we just leave it as 2 times 3 plus H?
We can for the moment, but we're not going to be able to long term.
What?
Now, my denominator is the H times the 3 times the 3 plus H. Let's clean this up a little bit. On top, I am going to have to distribute because why am I going to say he wants to cancel a 3 plus H? I'm going to veto. I'm going to veto because on top this is subtracting. I could cancel the 3 plus H from the bottom because it's all multiplied. But on top that is a subtraction.
So if we didn't have 6, we could do that.
Yes. But the 6 is there, so this is 6. If we distribute the minus 2, it's minus 6. Not plus H, it's now minus 2H. On bottom, we have H times 3 times 3 plus H. What happens on top? 6 minus 6 cancels. I have the limit as H approaches 0 of negative 2H over H times 3 plus H. Notice what cancels. Because now I'm willing to cancel. H cancels. and you're going to be ready to take your limit. The limit as h approaches 0 of -2 over 3 times 3 plus h. But we're going to plug in what for h? 0. And we're going to get -2 over 3 times 3 plus 0, which is -2/9. Shocker on the answer, right? Sorry, that one I forgot the work was a little bit more challenging there. So, okay. We'll talk tomorrow about our interchangeable vocabulary here and look at the next 2 pages.
Okey dokey.